Two addition and subtraction identities. These are fun identities to work with. A few times, though, they get pretty easy to use. But they look a lot messier than they really are. So the addition and subtraction identities, let's go ahead and look at what they look like in a moment. Okay, so here's the identities themselves. So it says if I have a sign of something plus something else, that's the same thing as sine x cosine y plus cosine x sine y. If I have a minus sign, notice it's exactly the same, except for there's a minus in the middle. Cosine's a little different. Cosine, the plus has a minus, and the minus has a plus. And the rule is slightly different. It's cosine x cosine y minus sine x sine y. And then cosine x cosine y plus sine x sine y. So again, you'll use them. You don't have to memorize them. They're going to be on your sheets. But the more you use them, the easier they are to remember how to use them. So why would we use these and how can we use these? Let's look at a couple of examples. So I have this problem here, cotangent of x plus pi. And I want to be able to simplify it. Okay? I don't know what x is. And so at this point I have to be able to, and I can't just do cotangent of pi. It doesn't work like that. So I have to use my rules to simplify this. So let's look at how we do that. So first of all, I know that cotangent is the same thing as cosine over sine. So I'm going to do the cosine of x plus pi over sine of x plus pi. And then I'm going to use my rules. Okay. So cosine is the same thing as cosine x, cosine y, cosine pi, sorry, minus sine x, sine y, over, or sine pi, sorry, it's pi in the problem here. Sine x surely I knew what I was doing. Sine x cosine pi plus sine x, or sine pi cosine x. All right? Now, I know what cosine and sine are of pi, right? So I know so the cosine of pi is -1 and the sine pi is 0. Okay, I know that from my unit circle. I think I got interrupted here, sorry. So cosine pi equals -1. There we go. And sine pi equals 0. There we go. So I end up with, so this one ends up with a negative cosine pi because this is 0 over a negative sine, cosine x, and then over a negative sine x, which gives me cotangent of x. So the cotangent of x plus pi is the same thing as cotangent of x. Isn't that nice? Okay, practice one. So you're going to try this one on your own. Go back to those rules, plug them all in, and see what you can do with them. And I paused here a little bit because I lost the problem. I couldn't find it when I was looking on the page. Because on my board there was a glare. There, and so I found it and moved it. So I knew where it was. Okay, so here's your solution. Okay, so we use the rules and we end up with sine pi cosine y minus cosine pi sine y. And that gives me 0 cosine y minus -1 sine y, which gives me just a positive sine y. All right, again, we're going to simplify here. So again, just using the same rules. This is the same stuff over and over again. It really doesn't get any more complex than this. So I end up with sine x cosine y plus sine y cosine x minus, parentheses, sine x cosine y plus, minus, so it's minus. Sine y cosine x, okay. And then I'm going to distribute that minus, and I can start canceling. I think I went a little slow there. Oh, no, I went ahead and did it, all right. And then I ended up with a sine x plus sine y cosine x plus sine y cosine x, and I get a 2 sine y cosine x. Easy peasy. Okay, here's your practice problem. Give it a whirl. all right? This one is weird, and we might have to talk about this one tomorrow, because what you're looking at, the idea of we're going to, instead of working this all out, I want you to think about, go back to the rules and see if you can work backwards, okay? Saying that if we called this just 1, say z, okay, sine z, cosine y, cosine z, sine y, okay, is there a way that you can go backwards? All right, it's tricky. All right, maybe? Okay, so actually I had to write this one out. And again, this was a tricky one. So if I went backwards, I end up with sine, maybe, of x minus y plus y, because I went backwards, all right? So that equals the sine of x because negative y plus y is 0. So that whole problem equals sine of x. And it's real basic like this. And I'll probably talk about this one tomorrow if you need me to. Okay, continuing on. Example 3. Okay. This is a proof. I need to prove that this is the same thing as that, so I'm going to work this side out until I get there. So I'm just going to work it out first. So it's sine x cosine pi minus sine pi cosine x, okay? And then I can remember that cosine pi is negative 1 and sine pi is 0, okay? And then I can continue, and I end up with a negative sine x, which is what I was trying to prove. And remember, show all of your steps. If you're not showing your steps, you're not getting any points for this. Okay, I have to be able to logically follow your steps from one point to the next. So here's your practice problem. Solution. Okay. Cosine x, cosine pi, minus sine x, sine pi. Okay, again, remember that cosine x, pi is negative 1 and sine pi is 0. All right. Which means I end up with a negative cosine pi, or negative cosine x, which is what I was looking for. I was trying to prove. All right, we'll see you tomorrow.